Hello friends, in this session we will be discussing about Introduction to Digital Electronics. Electronic systems are of two types, analog systems and digital systems. Analog systems are those in which voltage and current vary continuously through the given range. They can take infinite values within the specified range. For example, the output voltage from an audio amplifier might be any one of the infinite values between say minus 10 volt to plus 10 volt at any particular instant of time. Other examples of analog devices include signal generators, radio frequency transmitters and receivers, power supplies, electric motors and speed controllers, and many analog type instruments, those having pointers that move in a continuous arc across a calibrated scale. While a digital system is one in which the voltage levels assume a finite number of distinct values. In virtually all modern digital circuits, there are just two distinct voltage levels. However, each voltage level in a particular digital system can actually be a narrow band or range of voltages. Digital circuits are often called switching circuits because the voltage levels in a digital circuit are assumed to be switched from one value to another value instantaneously. That is, the transition time is assumed to be zero. Switching circuits may be a combinational switching circuit or a sequential switching circuit. In combinational switching circuits, the output depends only on the present inputs, whereas in the sequential switching circuits, the output depends on the present inputs as well as the past inputs. Digital circuits are also called the logic circuits because each type of digital circuit obeys a certain set of logic rules. The manner in which the logic circuit responds to an input is referred to as circuit's logic. Digital systems are used extensively in computation and data processing, control systems, communications, and measurement. Digital systems have a number of advantages over the analog systems. That is the main reason for the shift from analog to digital technology. Advantages of digital systems. Digital systems are easier to design. Digital systems have only two voltage levels, high and low, so they are easier to design. The exact numerical values of voltages are not important. Only the range in which they fall is important. In analog systems, signals have numerical significance, so their design is more involved. Information storage is easy. There are many types of semiconductors and magnetic memories of large capacity which can store digital data for periods as long as necessary. Accuracy and precision are greater. Digital systems are much more accurate and precise than the analog systems because digital systems can be easily expanded to handle more digits by adding more switching circuits. Analog systems will be quite complex and costly for the same accuracy and precision. Digital systems are more versatile. It is easy to design digital systems whose operation is controlled by a set of stored instructions called the program. Anytime the system operation is to be changed, it can easily be accomplished by modifying the program. Even though analog systems can also be programmed, digital circuits are less affected by noise. Unwanted electrical signals are called noise. Noise is unavoidable in any system. Since in analog systems the exact value of voltage are important and in digital systems only the range of values is important. So the effect of noise is more severe in analog systems. In digital systems, noise is not critical as long as it is not large enough to prevent us from distinguishing a high from a low. More digital circuitry can be fabricated on IC chips. The fabrication of digital IC is simpler and economical than that of analog ICs. Moreover, higher densities of integration can be achieved in digital ICs than in analog ICs because digital design does not require high voltage capacitors, precision resistors, inductors, and transformers like the analog design. Reliability is more. Digital systems are more reliable than the analog counterparts. Disadvantages or limitations of digital systems. We are in an analog world. Most of the processes are analog in nature. When these processes or quantities are processed and expressed digitally, we are really making a digital approximation to an inherent analog quantity. Instead of processing the analog information directly, it is first converted into the digital form and then processed using the digital techniques. The result of processing can be converted back to the analog form by interpretation. Because of these conversions, the process time increases and the system becomes more complex. However, in most cases, these disadvantages are outweighed by numerous advantages of the digital techniques. However, there are situations where use of only analog technique is simpler and more economical. Both the analog and digital techniques can be employed in the same system to advantage. Such systems are called hybrid systems. But the tendency today is towards employing digital systems because the economic benefits of integration are the overriding importance. Reference: this lecture has been prepared from the book Fundamental of Digital Circuits by A. Anand Kumar, 3rd edition, Prentice Hall of India Limited, New Delhi. Thank you.